Right. So in the last class, guys, we have gone with information gathering. That was trying to get information about a target system or a target organization passively. The next phase is scanning, which is also commonly known as enumeration. And the main objective of scanning here is the process of gathering information, extra information, but with active methods. Okay. So again, getting information such as the active devices in the network, open ports on those devices, services running on them, and the vulnerabilities on those services which could be exploitable is called as this is a piece of information you're trying to gather, and this is obtained by making active and aggressive connections. So depending on what kind of information you're getting, we can categorize the type of scanning as well. Okay, so there are three main broad categories. There's network scanning, port scanning, and vulnerability scanning. In network scanning, we figure out in the target organization, in their network, how many devices are available, how many active hosts are available, okay, and what their exact IP addresses are. Once you know what those devices are available, then you perform port scanning on them to figure out what open ports are available on them and what services are running on them. Okay. So again, you have multiple TCP and UDP services on a system, and we try to identify those services in port scanning. Okay. And then finally, we have vulnerability scanning, where once we know what services are running, we find the loopholes on those services now, okay, which can make the system exploitable. Okay. So first things first, we already know what active hosts are, but today we are coming across a new term called ports. So let's talk about these ports today. Okay, what are ports and what are the categories of ports? So when you talk about ports, guys, usually there are two categories of ports on your system. There's something called as physical ports, and then there's something called as logical ports. Physical ports are the ones which are actually visible to you on the device. The USB port, the HDMI port, the VGI port, the charging port, you could say. Okay, all these ports allow you to transfer media or transfer electrical power to the device. Okay. Now, we are not talking about those ports here. We're going to focus on logical ports. Logical ports are something which are same on any device. No matter what device you take, no matter what laptop or computer you take, it has the same number of logical ports. These logical ports refer to the software-based or virtual communication entry and exit points for the system. Okay, and these ports are used or are very essential for enabling communication between your device, okay, and other devices. Okay, or even in your device, when one service or one application wants to communicate with another service or another application within the system or across the systems in a network, these ports are used for it. Okay. And again, these logical ports also have three important categories, guys. Depending on what services are being run, these again logical ports will change as well. Okay. So as mentioned, your logical ports range from the number 0 to 65535. There are around 65,536 logical ports, no matter what device you take. Okay. So just give me 1 minute, guys. Someone's at the door. Let me quick. Guys, there are three categories of ports. The first category of ports is called as well-known ports. Okay. And these port numbers range from the number 0 to 1023. And they're reserved for commonly known services or well-known services. Now, if I show you what those are, if you go back to your browser, um, in your browser, you can search for well-known ports. And you get a list of ports with some services attached to it. So you can click on any of these websites. And you can see every port number within that range from 0 to 1023 has a service attached to it. So port 20 is used for FTP. Okay, this is for FTP client, and 21 is for FTP server. 22 is for SSH service, secure shell. 23 is for telnet. 25 is for SMTP. Okay, 53 is for DNS. So whenever there's a DNS server, when it wants to again resolve any IP to a domain name and vice versa, that device will always have the port 53 open on it to receive the DNS requests. Okay. When you're having a web server which is hosting a website on HTTP or HTTPS, it will run on the port number 80 for HTTP or 443 for HTTPS. If we scroll down, there's 443 for HTTPS. So as you can notice over here, for every commonly run service on any device, there's a certain port number fixed for it. These are known as well-known services. So these services are available on every system on the internet. Okay. And these services have a port number fixed for them. That service will only run on that port number and nothing else. Okay. So it's quite important to remember some of these port numbers, guys, because in the upcoming sessions, when we access a lot of log files and all, you'll see these port numbers. So from that port number, you have to figure out which service might be running on it. Okay. So at least the most commonly used ones, the ones which are highlighted here in blue, at least you need to remember those port numbers. Okay. 20 for FTP, 21 for FTP as well, 22 for SSH, 23 for Telnet, 25 for SMTP, 53 for DNS, okay, 80 for HTTP, 443 for HTTPS, etc., etc. Okay. Now, as mentioned, these are all the well-known ports, services which have the port numbers fixed. And again, services which are by default available on every system. But now, not just these services, sometimes devices contain third-party services or third-party applications as well. Okay. And those third-party applications use the registered ports from 1024 to 49151. This entire range is used for third-party applications or services. So if I go to my desktop here, you can see there's a lot of third-party apps. Okay. There's Proton VPN, there's VMware, there's Epson printer applications, OpenVPN, Zoom, Telegram, Brave, and GoToMeeting, etc., etc. So all these applications, third-party applications, also require ports for communication from this device to foreign devices or other devices. And these applications use the registered ports 1024 to 49151. Now, there's one more third-party application which uses a lot of connections as well, and those are your browsers. And your browsers use the dynamic ports. So dynamic ports ranging from the number 491522655535 are used for dynamically established connections. Okay, so your browser connections are very dynamic, are very spontaneous. So those connections are made on the dynamic ports, okay, for temporary or dynamic services. Okay, so again, if I'm using my Google Chrome browser, Firefox browser, Safari browser, whatever browser it be, all these browsers will use dynamic ports for connection. Okay. So for example, let's say if I'm connected from my system to google.com on a browser, this is what the connection would look like. So from my device here, if I'm connected to, oh, sorry. Yeah, so this is my device here. And let's say this is a server here, google.com, www.google.com. And since Google runs on HTTPS, https://google.com, HTTPS always runs on port number 443. Okay, so let's assume this is my device here. And let's say this is Google's IP here, something like 142.250, some random IP. And now when I'm connecting to Google from my browser would always use a dynamic port from 49152 to 65535. So let's assume if this is using the port 50,000. Now this is the connection that will be formed from my device to the foreign device. Okay, so the connection would look something like this from my system 192.168.0.10 colon port 50,000. I'll be connecting to the foreign system 142.250.193.221 on the port 443. So your IP and port numbers are mentioned with a colon symbol in between. So the first here, before the colon, you have the IP address, and after the colon, you have the port number. So on your system, you're using this port number. So on your IP, you're using this port number, connect to the foreign IP on this certain port number. Okay, so this is what the connection looks like. Okay. So now we're going to learn how do we check for these connections on our own system, understanding our own port system's port status. So for that, there's an inbuilt tool in your application itself, in your system itself, guys, called NetStat. So we're going to talk about NetStat. But before that, any questions or doubts up to this point? Vamsi, Bhavan, oh sorry, Charles, Wahab. Hello, guys, are you there? Charles, any questions? Okay, right. Wahab, any questions on your end? Vamsi, any questions on your end? Anything that you didn't understand that you want me to explain again? Do not hesitate to let me know. Okay, right. So, oh, 1 second. Right. No questions. So moving forward. So as mentioned, we have an inbuilt tool in our system, guys, called NetStat. It's a terminal-based tool. It's pre-installed in any operating system, Windows or Linux. And basically, it's a command line tool, a command line utility to perform or to check or give you information about your port statuses and your network connections. So if I go back to my terminal here, and in my terminal, if I run the command netstat, and if I hit enter, you can notice I've got some information here. In the first column, it says protocol. And under protocol, sometimes it might show me TCP or sometimes it might show me UDP. Then it says local address, which is my address and my port number. Then foreign address, the target system I'm connecting to and their port number, and the state of the connection. So let's talk about the state, guys. What is established, what is close, wait, etc., etc. So there are 5 important port statuses, guys. To explain them, let me use a simple diagram. So, so let's assume over here. Let's assume this is my device here, and there's a foreign device here. Okay, and so let's assume these devices are running some services on them. So whenever there's a port open, which basically means when there's a service running on it, when there's an application running on it, that port is by default always in something called listening state. Listening is where the port is open, some service is running on it, and it is waiting for a connection. Okay, that's what listening stands for. So if I write it down here, listening is for port, open port with the service running on it and waiting for a connection to be established. Okay. Now, when one of these devices does initiate a connection, so let's say my device initiates a connection, one of the foreign system reciprocates it back. Then in such a scenario, when a connection is formed, then the ports change into something called established. Okay. So again, when there's a connection formed between the two devices, when they're transmitting data to each other, rather than just staying open. In that scenario, the ports are supposed to be in established state. Okay. So established is where ports are now established. This is where ports are now connected and they are transmitting data to and fro. Okay. Now, while this is happening, let's say one of the devices gets some issue on it. So let's say if our device has an issue on our port and if the connection gets terminated, let's say from our end, in that scenario, if the connection is on, if the connection disruption is on our end, then it is called as time wait. Time wait is where the connection was established earlier, but due to some issue on our system, the connection got closed or terminated. Okay, so if I write it down here, so time underscore wait is where connection was established earlier, it's established properly earlier, but later got disconnected or got interrupted, let's say, from our end. Okay, so when the issue is on our system, it is called as time wait. And if the same thing occurs on the other system, that's called closed wait, closed underscore wait. So closed wait is where everything is fine on our system. There's no issues on our device. It's the issue on the remote device. So if this port goes down, for them it's going to be time wait, and for our system now it's going to be closed wait, closed underscore wait. Okay, so closed wait is where connection was established or was established earlier, but later got disconnected from the other end or from the remote end. Remote is the other system, other end. Okay. And now there's finally one more type of a port status called SYN. So this is usually when the other system doesn't accept your connection. So if the connection gets accepted, then the ports change from listening to established. Okay. So let's assume there were no connections yet. There were two ports in a listening state. And if one device sends a connection, this connection is established with something called a SYN flag. We'll talk about those flags later on, guys, in the next session. Don't worry. Okay. There's something called TCP flags. Okay, don't worry about that. But basically, it sends a packet called SYN, so it stands for synchronize. Okay. So when that flag is sent and if the other system doesn't accept it, then the port goes into something called SYN send. Okay, so there's something called as SYN send. SYN underscore SENT. This is one more port status where port was in a listening state. Port was in a listening state and it tried to establish a connection. But the other system, or the other device, or the remote device didn't accept the connection. Okay, so this is the SYN port status. So these are the 5 most important port statuses, guys. There are others as well, fin, wait, etc., not so important. But these are the 5 which you commonly see in the netstat command. Okay. Now let's try to see each of these connections. Okay. So when you run the netstat command, guys, by default, when you run netstat, it doesn't show the listening connections. It only shows established time wait and close wait. So from your system, whatever connections are established to the foreign system, or even if they are terminated, only those type of connections are shown. If you want to see the listening connections as well, then you run the command netstat -a for all types of connections. And now when you hit enter, you can see it shows both established and listening connections as well. So from your system, these ports are being used, okay, to run some service and they're waiting for a connection. They are not connected to any foreign system. There's 0 updates. Okay. Only when a connection is established, then you can see a foreign address here. If it is in a listening state, you will not see any foreign address. Okay, because it is not connected to any foreign system yet. Okay. So netstat -a is to show you both listening connections and established time wait or close wait connections. Okay. Now, in most of these connections, we see the host names rather than IP addresses. Okay. So if you want to see what random IPs we are connecting to, what foreign IPs we are connecting to, for that you can run the command netstat and -a for all and n for numbers. So to translate IP address, to translate domain names or host names to IP address numbers, we give the option n. And now everywhere we would see the IP addresses. Okay. So whenever there's a foreign system connected to your device, or when the attacker is connected to you with the Trojan attack, even his connection can be found here. So one of these IPs could belong to the attacker's system. Okay. There are ways to verify that. We'll talk about that later on. Okay. But basically, whenever you're under an attack or a cyber threat attack, it's your responsibility to take a screenshot of this command actually. Okay. And figure out, again, this allows us to know which foreign systems are connected to our system at that certain point of time. Okay. Similarly, if I'm connected to Google as well, even that connection should be shown here, guys. Okay. So for example, if I go back to my browser here, and in my browser, if I open up a new a new tab and search for Google here, even this connection should be shown to us in the netstat command. So I'll run a new command here called netstat -a-n-o. So there's a new option here called a. Okay, so now when I hit enter, you can see there's one more extra piece of information called PID. I'll talk about this in a bit. But one of these connections should belong to my Google guys. So usually I'll go for the last connection form. So this is the last established connection. And you can see from my system, I'm using a port 55,979. This is the dynamic port connecting to a foreign IP, public IP 142.250.77.138 on the port 443. So if I copy this IP and if I go back to my term browser and if I paste this IP here, carefully observe, this is my Google connection form. Okay. So from my system, I'm using a dynamic port, a browser port to connect to a foreign IP for Google's IP on port 443. And if I have to kill this connection, I need this process ID provided with the option A and O. O stands for process ID. And with this process ID now, I can kill this connection if I want to. So I can run the command task kill /F to forcefully kill it, and then /PID for the process ID. And I can mention this process ID 20,344. So now when I give that process ID here, 20,344, carefully observe the browser now in the background. When I hit enter, the browser automatically closes. So this is how you can kill any foreign connection as well. Okay. To kill the connection, you need the process ID. And that process ID is provided with the option O. Okay. A for all types of connections, N for IP address numbers, and O for process ID. And I've mentioned that here clearly. Any questions, any doubts up to this point? Mhm. Mhm. Uh, right. So, as the saying goes, Charles, prevention is better than cure, right? So the only way you can prevent these kinds of attacks are at application level. So most of these attacks can happen from Trojan applications. So when you click on links from unknown sources and download applications from unknown sources, these applications generate those sorts of connections. So the only way to prevent them is basically, as mentioned, by not clicking or running those applications. But by chance, if you do, and after you do, there's no way, frankly speaking, of trying to figure out randomly when those connections have been formed. You just have to keep scanning your system once in a while for malicious applications. Okay. So from this, just by out of the blue, you will not ever get to know that someone has established a connection to you. So you first prevent those types of connections by not installing such apps. And just in case if you did without knowledge, you scan your systems from time to time with certain applications to know if there are any malicious connections. We'll talk about what those tools are to scan your system for such malicious connections in the upcoming sessions. Yeah, go ahead. Again, it's basically from the application level, Charles, as mentioned. So from these connections, you cannot figure out which of those IPs could belong to an attacker directly. You just have to do a trial and error method, copy each IP, go to the browser, and in the browser, figure out who that IP belongs to. So for example, if there's this connection here, which I just killed from google.com. So if I copy this IP now, and if I go to my browser, and in my browser, I can search for something called IP lookup. So this tells me who that IP belongs to actually. So if I go to IP lookup here, and if I paste that IP address here, and now when I click on get IP details, it tells me which organization this IP belongs to. So as you can see, it says belongs to Google LLC. Okay. So again, if you click on this button here, check for blacklist status, it tells you if this IP has been blacklisted by someone as well. So most of the DNS servers have listed it out as a safe IP, as you can see. If you see red colored listing, it means that this is a malicious IP also. So this is one way to figure out if an IP is safe or not. But again, you would never randomly go and check for this, right? So it's better to check for application level on your system if there are any unknown applications which might be installed and which might be creating such connections. Okay. You going to the netstart command, checking for each IP is a troublesome process. It's quite a hectic process. You can't keep checking it every day. But rather than that, you can check for applications installed on your system which are generating these kind of connections. Okay. So we'll learn that how to scan for those applications, malicious applications in the upcoming sessions. Okay. Right. Now moving forward. So this is the terminal based version, guys. There's a graphical version as well. Now don't scold me for not showing that first. Okay. The reason I didn't show you that first is because that's a third party app. And in an organization, they will never usually allow you to run third party apps, guys. They'll always prefer you use the inbuilt tool NetStack. Okay. But just in case if this is your personal computer, you're free to use any app of your choice. So you can go to your browser and search for this application called Kerports. So this is the graphical version of NetStat, I would say. Okay, but it's a third-party app which gives a lot more detailed information more than NetStat. So click on the first link, scroll down, click on download links here. Download purpose for 64-bit. And once downloaded, oh, I think it should be in my downloads folder. And oh, I don't have it here. No, it's here, compressed. So you'll have a file here, which is around 129 kilobytes or so. Right click on that and run it as, extract it first. And once extracted, open up the folder and you have a Kerports application, Cports, a very lightweight application. Doesn't require installation as well. And this is what it looks like, as you can see. And here, graphically, it shows you what is the process application. Oh, 1 second. Yeah, better. So as you can see, it shows you what are the applications running that process, what is the process ID, what is the protocol used, TCP or UDP, what is the local port, what is the local port name. Okay, so what service could be running on it, what is the local address, what's your IP address, what's the remote port you're connected on, what's the remote port name, what service is running on it. Okay, remote address, remote host name, and the state of the port, listening, established, time, wait, etc. Same information, exactly what you got in NetStat, but in a graphical way. And actually gives more information as well. It also shows you how many packets were sent, how many bytes of data was received or sent, what is the path of the application running that process. So from here, you can figure out which application is running that certain process, okay, who the process manufacturer is, okay, who the vendor for that product is, etc., etc. Okay, when was the process created on, what time, what did the process get started? All that information is available here in Kerports. Okay. And if you want to kill any sort of connection, let's say my browser is running here in the background, and if I want to kill my browser, right click, kill process. Yes, confirm. And now the browser is closed. Oh, 1 second. I think I didn't click on that. Yeah, now it's closed, as you can see. Even my go-to connection has, the meeting we are connected right now, even those has some ports connection established, as you can see. Some dynamic connections. So if I want to kill my meeting, I can right click on any one of this and click on kill process. And that would kill our connection as well. Okay. So again, as mentioned, NetStat is a terminal version. Kerports is a graphical version. But you usually never install Kerports on organization systems because it's a third party app. And people, in your organization, your company might tell you not to run any third party apps which are from unknown sources. But if it's your own computer, you can feel free to run Kerberos. It's a pretty safe application. I've tested it rigorously for malwares, and it always came out safe. Okay. So yeah, that's about it. Yeah. Yeah. Hmm. Hmm. No, I get it. I get it, Charles. It's a very good question, actually. But basically, as mentioned, this method I've shown you, this is only for your own system, Charles. It's for understanding the port status of our own device, not for foreign devices again. So from for foreign devices to scan other systems and to see what ports are open on their systems, what services are running on their systems. We have other tools for that. We have tools called Nmap. Okay, so this is a tool we are going to learn in the upcoming days. Nmap, Network Mapper. So this tool allows you to scan other devices from your device. You can figure out on their system what ports are open and what services are running. And if you want to figure out if they contain malwares or not, that is possible with another tool called Nessus. It's a vulnerability scanning tool which can scan for both malwares and misconfigurations or vulnerabilities as well. So yeah, there are tools which can perform what you are asking for, okay, from your system remotely on any other device in the network. Okay. But again, there are other tools for it. We'll talk about those tools as our classes progress. We'll be working on those definitely. So yeah, that's that, guys. Nothing further. In today's class, we learned what ports are, what are the different categories of ports, three main categories. Again, well-known, registered, and dynamic. And then we learned how to check the port status of our own system. In the next class, we're going to learn from our system how do we scan the other ports of other devices. Okay, we'll be talking about this tool called Nmap and some important protocols called TCP and UDP. So if you remember, in the first line, we had something called TCP and UDP here. Okay, we didn't discuss about that. So we'll talk about what TCP is, what UDP is in the next session. Okay, we'll cover all that in the next class. Okay. So yeah, that's that. Nothing further for our session today, guys. I'll be sharing this notes and the recording shortly. Bye-bye. Have a good day. I'll see you tomorrow at the same time. Thank you, guys. Bye.